Okay, before we begin, I think it's always a good idea to write different ways that you can prove triangles congruent. So yesterday we learned about SSS, SAS, ASA, and AAS. Or you could also say SAA. Okay, those mean the same thing. Remember that if we are working with SAS, then the angle needs to be in between the two sides. And if we're working with ASA, the side needs to be in between the two angles. Okay? No bad words in math class and no card trouble in math class. So, nice little surprise for you guys is now that we are past chapter 2, all the definitions you don't need to write out anymore. If you want to, you can, but like definition of an angle bisector, you don't have to write anymore. If an angle is bisected, then it divides it into two congruent parts. You can just say definition of an angle bisector. Same thing with midpoint. Instead of saying if a point is a midpoint, then it divides a segment into two congruent parts, you can just say definition of midpoint. Surprise! Okay. All right, so let's start off with number 1. AD is congruent to CD, and angle ADB is congruent to CDB. So it is always a good choice to mark your given information on your diagram. So we know AD is congruent to CD, and we know angle ADB is congruent to angle CDB. Okay, so I have an angle and a side. So if I look up here, I have an angle and a side. So I'm probably not going to use SSS. Okay, then I am going to look at these three. Can I prove one of these? Well, if I look at my diagram, is there anything else I can prove? Well, I can. This whole DB is congruent to itself by the reflexive property. So DB is congruent to DB by the reflexive property. Okay. So now if I trace this, I have a side, an angle, a side. Side, angle, side. So these two triangles are congruent by SAS. So triangle ADB is congruent to triangle CDB. Remember that order matters. Okay. And then also, I think it helps to write down the steps that you found it to be congruent. So we got the side from step 1, we got the angle from step 1, and we got the other side from step 2. So 1, 1, 2 to prove it true. Okay, let's go to the next example. So again, let's write down our given. So AD is congruent to CD, and B is the midpoint of segment AC. So the only thing we can mark on our diagram that's given is that the AD is congruent to CD. Now, we have a midpoint. Remember that anything with a midpoint, a perpendicular, a bisector, needs to be broken down. It needs to be dissected. So step 2 is going to be, it says B is the midpoint of AC. So I can prove that these two are congruent. Remember, order matters. So AB is congruent to CB. And here's where the surprise comes in. You can just write definition of a midpoint. Okay, if you want to still write everything out, you can. Theorems we still need to write out, but definitions we can just say definition. Okay, well, if I go up, I have SSS, SAS, AAS, and ASA. Which one can I prove? Well, I have two sides so far, so that eliminates two of the options. So I have SSS and SAS left. Well, is there anything else I can prove? I can prove DB is congruent to DB by the reflexive property. So now if I trace this out, I have a side, side, side. So this is congruent. So a triangle ADB is congruent to triangle CDB by SSS. Now let's go through our steps to make sure that we have everything. So we used something from step 1, we used step 2, and we used step 3 to prove my triangle congruent. Okay, in the next example, let's always start with our given. So we have angle A is congruent to angle C. And we have ray DB bisects angle ADC. So the only thing we can mark on our diagram right now is that A is congruent to C. It's the only thing we can mark. Okay. So remember that anytime you're given bisect perpendicular, you need to dissect it. So DB bisects ADC. So here is ADC. So I'm going to bisect that. So that means that angle ADB is congruent to angle CDB. And again, all you have to write is definition of angle bisector. You do not have to write out all of it anymore. Okay. So I have two angles. So SSS is out, SAS is out. So my two options are ASA and AAS. Well, what can I still prove? I can prove that DB is congruent to DB by the reflexive property. Remember that you have to prove, if you are working with the same segment or the same angle, you have to prove that it's congruent to itself by the reflexive property. So what do I have now? I have angle, angle, side, angle, angle, side. So to sum this up, triangle ADB is congruent to triangle CDB by angle, angle, side, and then mark the way you proved it. So I had 1 from angle 1, or step 1, and then step 2 was the blue, and step 3 was the green. So AAS by steps 1, 2, and 3. Okay, let's go ahead and go to the next page. Always start with our given. So IT is congruent to WN, and WI is congruent to TN. So IT, this full length here, is congruent to WN, okay? And then WI is congruent to NT. TN, sorry. Is there anything else we can prove? Yes, both of these triangles share IN. So IN, segment IN, is congruent to NI by the reflexive property. So I have 3 sides congruent, so I can do side, side, side. So triangle WIT is congruent to triangle TNI. Reason being is by side, 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 and then let's mark our steps. So we got 2 from step 1, and then we proved the third side in step 2. All right, let's move on to the next proof. We have just 2 left, but these are a little heftier in the sense that there's more to them than just the couple steps that we've been doing. So first, let's go ahead and write down what we know. okay? And then always mark them as well. So we know angle 1 is congruent to angle 6, and we know that angle 3 is congruent to angle 4. Vertical angles are congruent, okay? So first, let's dissect the information given to us. So R is the midpoint of UY. So that means that UR is going to be congruent to YR. And the reason being is the definition of a midpoint. Okay. All right, so right now we have two angles congruent, or I should say one pair of congruent angles and one pair of congruent sides. So that leaves me with then side, angle, side, angle, or angle, angle, side. I don't have any other information about sides, and if I look at my diagram, I don't have a side that's congruent to itself, so SAS is out. So can I prove that another angle is congruent? Well, since this is the side that we proved congruent, the non-included angle would be T and K. There's nothing I can prove about T and K though, so that means AS is out. So can I prove ASA somehow? Well, I know that 1 and 6 are congruent. Can I prove 2 and 5 to be congruent? Well, looking at the diagram, what information can I pull? Well, I know that angle 1 and angle 2, as well as angle 5 and angle 6, form a linear pair or straight angle. You can say either one, and that's assumed from the diagram. And because of that, we know that angle 1 and angle 2, as well as angle 5 and angle 6 again, are supplementary. And for here, I can just write definition of linear pair. I don't need to write out that if angles form a linear pair, then they are supplementary. I can just write definition of linear pair. Okay, so what does that tell us? Well, if I know that 1 and 6 are congruent from the given, and then 1's congruent to 2 and 5's congruent to 6, I can then conclude that angle 2 is congruent to angle 5 because if angles are congruent to supplementary angles, then they are congruent. So since this is a theorem, I still need to write that one out. So let's go ahead and mark this on my diagram. So I know that 2 is congruent to 5. Okay. And do I have enough information now? Angle, side, angle, and angle, side, angle. So these two triangles are congruent by ASA. So triangle TUR is congruent to triangle KYR. Remember, you got to follow order. So this would be by SAS, and then let's go through our steps. So we used that 3 and 4 were congruent, so it's from step 1, step 2 for the segment, and then step 5. So 1, 2, and 5. Okay, and we have one last proof to go. Okay, and sometimes it helps to draw these triangles separately. So it wants GEO. This would be angle 2. This was angle 3 and 4. And then we also have triangle EGM. So E was angle 3, then this is angle 1 and 2, and then M. So let's start off with my given. GM is perpendicular to GE. EO is perpendicular to GE. and angle 1 is congruent to angle 4. Okay, so we need to, all right, let's dissect the given. So if GM is perpendicular to GE, then we know that angle EGM is a right angle. And we also know that if EO is perpendicular to GE, then angle GEO is also a right angle. And the reason being is definition of perpendicular. Again, you don't have to write that out anymore. That step is actually going to help us twofold. So first of all, if we know that the angles are right angles, we know they are congruent. So angle EGM is congruent to angle GEO. Because if angles are right angles, then they're congruent. Okay, so let's mark that these two are congruent. Okay, well, we also know that they are complementary. And we're going to go ahead and use the numbers that I listed above. So angle 1 and angle 2, as well as angle 3 and angle 4 are complementary. Because if angles add up to a right angle, then they are complementary. So how does that help us? Well, if you look back up at top, we know from the given that 1 is congruent to 4. So if 1's complemented 2 and 3 is complemented 4, and these two are congruent, it follows then that 2 and 3 are congruent. So angle 2 is congruent to angle 3 because if angles are complementary to congruent angles, then they are congruent. Okay. All right, so let's go ahead and mark that on our diagram as well. So now we have 2 and 3 are congruent. Okay, so we know we're going to use some type of angle, side angle, or angle, side. Well, if we look at what I drew up separately, we can see that GE is congruent to GE. Both triangles share the same segment. So GE is congruent to EG by the reflexive property. And now I can say that these two triangles are congruent by ASA. So make sure that we follow order. So that's going to be triangle EGM is congruent to triangle GEO by ASA. Okay, and then let's mark what we proved congruent. So right here, we proved that in the green, we had a pair of angles congruent. Then we went to the red to prove the sides congruent, and then up to the blue, and you could have gone blue, red, green, or green, red, blue, it doesn't matter. Just make sure that the red's in the middle in order to use ASA. So 3, 6, and then 5. Alrighty, that's about the heaviest of the problems that we're going to see. I hope you guys enjoyed learning about how to prove triangles congruent today.